Okay, the question 4. Now this is good. This just says factorize. Okay, plain and simple. Sometimes they dress this up and they tell you to solve. Or there's different ways of saying this, but yeah, this one just says factorize, plain and simple. Okay, so there's a few different types of factorizing we should think about. Okay, the first one is just finding a common factor. Okay, so let's just write over here. We'll just say common factor. I'll just change my pen back to blue. And people find this hard, and it's not totally straightforward factorizing because there's a few different methods, and it does require sometimes just a little bit of thinking. Okay, but again, if you practice it, you should be okay. But yeah, the first one is just a common factor. So let's say I've got 4x squared plus 8x. Factorize. Okay, so we just find a common factor. Okay, we can say, well, 4x is going to give me 1 plus, x plus 2. Okay, so a common factor is a good place to start. The second method would be a standard trinomial. Okay, so again, I'll write over here, common factor. Okay, so common factor would be a standard trinomial. So say we get something like 6, or no, just x squared minus x minus 6. Okay, and what we're looking for is a number to add to give us this and multiply to give us this. Okay, so our brackets, we're going to look at this, and this last number, or these two last numbers, are going to add to give us this number and multiply to give us this. Now at that point, you have to think of your factors. Okay, so I always just write down all my factors for minus 6. We'll just say minus 6 and 1, minus 3 and 2, minus 2 and 3, minus 1 and 6. Okay, just in a nice list. Okay, and then think, okay, which of these adds to give me minus 1? It's probably that one, doesn't it? So at that point, I'd say minus 3 plus 2. So if I solve for that, x would be equal to 3 and x would be equal to minus 2. Okay, so that's just your standard trinomial. All right. So I'm just going to call that standard. Okay. The other one would be if it was a slightly complicated trinomial. Okay, now this happens when we've got the factor in front of the x squared. So say I had 3x squared minus 13x minus 10. Okay, that looks, we're like, oh, there's a lot going on here now. We can't take a common factor out. So what do we have to do? Well, I would get my table out. This is what I always do. I would draw a little table, and I think, well, what could the answers possibly be? Okay, so I know I'm going to have an x here, and I'm going to have an x here, and I know I'm going to have two numbers here and here. Okay, now, I know these two numbers have to multiply to give me minus 10. Okay, so again, I'm thinking, what are the factors of minus 10? Now I'm just going to try minus 5 and 2. Okay, I could have tried minus 10 and 1, could have tried 5 and minus 2. It's just a little bit of trial and error. Okay, so minus 10 goes in there. And now I want to have 3x squared in here. So it can only be 3 and 1. I don't know if the 3 is going to be here or here, but I know it's going to be 3 and 1. So I'll just try, let's put 3 in here. Okay, and I'll leave that as 1. So I get 3x squared. So right away I'm looking good. I've got 3x squared and minus 10. And now multiply the rest of it out. So that's minus 15x. And that's 2x. Oh, there we go. Okay, so first time, okay, got that. Minus 15x plus 2 is going to give me minus 13x. Okay, so your answer for this one would be x minus 5 and 3x plus 2. Okay, so just a little bit of trial and error, and we knew what we were going for. We knew I had to have a minus 10 in here and a 3 in here. Okay, and the question is going to be set up that there's not going to be a million different chances. Okay, there'll be about 4 or 5 potentials. Okay, maybe not even. All right. So it's just these two we're trying to make fit, okay, based on the variables we put in here and here. Okay, so sometimes you just got to move them around. So that's good. That's very good. So that's the more complicated one. The last two, I'm going to run out of space now, so I'll call that kind of complex. The last two is difference of two squares. Okay, so a difference of two squares. I see this point. I'm just to save me space. Sorry, I'm just going to rub this out. Okay. Difference of squares. This is when you have something like x squared minus 9. Okay, so you know x term. So you know that's going to have to be x plus 3 and x minus 3. Okay, so we know that because these two numbers have to multiply to give us the 9, and then they're going to be different signs for the x's to cancel out. Okay, so again, if I just go over here just quickly, I know I'm going to have x and 3, x and minus 3. So I know I've got minus 9, I know I've got x squared. Brilliant, that's exactly what I wanted. Okay, but because I've got these different signs, I know the 3x and the minus 3x cancel out. Okay, so that's your difference of the difference of squares, difference of two squares. Okay, so we basically just take this number and half it, and that's our answer. And again, you can always multiply it just to check. So if you don't see an x in there, that's what you're thinking of. And the very last one is complete the square. Okay, now complete the square looks a bit like x, say it was like x plus 4 squared minus 13. Okay, that's the way it looks. Okay, there's a square term and then there's a number on the outside. All right, now to actually get this number, kind of running out of running out of space on you. I'll just, you know what, I'll keep that answer in there. I'll write x plus 4 squared minus 13. In fact, sorry, the example I'm looking at, the final answer is minus 29. Okay, I'll just keep that in there and I'll just call that complete the square. But just a little bit of a recap on why that is. If we were given something like x squared plus 8x minus 13, we might think that's just our standard original version, isn't it? Okay, so we've got a common factor, we've got standard, complex, difference of two squares, and complete square. We might look at this and say, oh, this is just standard, isn't it? But what adds to give us 8 and multiplies to give us minus 13 doesn't work. Okay, so what we do is we look at this term separately, okay, and we half this 8. Okay, so we end up saying x is 4 and x is 4. Okay, so that's x squared, 4x, and 4x, which is brilliant. So that's x squared plus 8x, which is just what we wanted. But now we end up with a plus 16, which we didn't really want. We never had that. So what we do is we rewrite this as x plus 4 squared minus 16, and we've got our minus 13 from the beginning as well. Okay, and that's where you get the minus 29 from. Okay, so we just half this number in here, and then say it's x plus that half number. Okay, so that was x squared plus 9x. That'd be x plus 9 over 2. Don't be afraid to use fractions. If that was x squared plus 10x, that'd be x plus 5. Okay, and we just take away this number we've generated. We've generated this number, and we don't want it. Okay, so our simplification has kind of created this number which we take off. Okay, so if you look at a standard one, sometimes it could look like a complex one. To be fair as well, that'd be quite mean. But it might just look like a standard or maybe a complex one, and then that's how you would get around that. Okay, so those are your different ways of solving it. Okay, that's the tools in your toolbox. Okay, so literally no paper left. You know what I'm going to do? I am just going to, where can I solve this? That's right. I'm just going to solve it up here in the top right. Okay, so 3x squared minus 48. Oops, minus 48. So what do you think about that then? Looking at our different methods. Okay, now I'm spotting right away a common factor. Okay, so I'm thinking a common factor with 3, but also there's no x term. So with no x term, I'm thinking difference of two squares. Okay, so let's see if we can get the 3 out first of all. 3 bracket x squared minus, what would 3 and 34 be? 3 and 40 be 1 remainder a 16. Now that's definitely looking like a difference of two squares, isn't it? Okay, so if we want to get difference of two squares, we're going to half that number, aren't we? So it's going to be 3 bracket x minus 4, x plus 4. Yeah, and again, let's just check. Let's just say x minus 4, x plus 4. So that's going to give me x squared minus 4x plus 4x minus 16. Looks good to me. So they would cancel out. That would give me this. Okay, brilliant. So again, there's a lot in factorising, and that's why I thought this work. I would just take a bit of time to go through. Okay, but don't forget your common factor. The standard one is very straightforward, adding and multiplying. Complex one's a bit of trial and error, and you're going to base what you get off the back of work. You know what your factors are for minus 10, and you know what your factors are for 3. Okay. I think difference of squares is possibly the easiest one because we just literally half this. Okay. Or not half it, sorry, find the multiples of that. Sorry, I don't know if I said half up here actually. Sorry, I might have said half. I meant multiples. Sorry. But yeah, we're just finding the two multiples, and it's this number in here to complete the square, or we'd half it. Okay, so complete the square is maybe a bit tricky. But again, when you see these written down, you think, well, that's not too bad. But there are different ways of doing it. It's not just one method. So that's what people can struggle with. Okay, so you've got options. People might have looked at that and said, well, maybe that's a complex one. You know, you could, I suppose you maybe, let's think, could you have done it? Yeah, maybe you would have said, if you'd said a 3x, let's see, you might have said 3x plus 12, because you might have said, well, I know 3x and x is going to give me 3x squared. And you know, so you said 12 and 4, okay? 12 minus 4 are going to give me minus 48. You might have looked at that and said, well, that works, doesn't it? Because now you've got 12x up here, minus 12x down there. Yeah, so you might have said 3x plus 12 and x minus 4. That is almost a valid answer right there. Because you've almost gone for the kind of the complicated method in a way, because you say, well, what's my factors of up to 48, and what multiplies to give me 3x squared, and then you've made this work in the middle, so minus 12x plus 12x is 0. But what you then would need to do is take your common factor away from here, yeah? So you'd then say 3x plus 4, x minus 4. Okay, so again, there are different ways of doing it. But I think for this one, the easiest thing to have done first was take out your common factor, and that makes the factorising just a little bit easier. All right. But yeah, I hope that's helpful. Just going through some of the different methods of factorising. Time, right? That's me. Time up for that one. Okay, so quite a bit in that video for such an easy question. Really, 2 marks. Like I just went over it in about 10 seconds almost. But it is worth just thinking about these things. Are there common factors? Is it my standard method? Is it my trial and error method? Difference of squares, I just need to multiply to give us this. So if you don't see an x, think difference of squares. And complete the square is when you maybe just can't figure out a way of doing it, okay? You can't do the normal trinomial method that we just talked about, the standard and complex. So you have to look at this part of the equation on its own, manipulate it, and then put together these two numbers, okay? So yeah, practice, and as you practice, you'll start to recognize it. But that should have jumped out as difference of squares. Okay, thanks very much.